Hey guys, I hope you're doing great today. This is our chapter number 37 of our DevOps Roadmap 2024, in which we are going to discuss and we are going to learn about the Kubernetes architecture. So you can say that it would be our third chapter of our Kubernetes course, and we are going to cover a lot of Kubernetes tutorials for beginners. Guys, in the previous two chapters, we discussed what is Kubernetes and what is Kubernetes used for. And I'm not sure how do you pronounce it, but I used to say it as Kubernetes while I was just checking Google and it was saying as Kubernetes. So that is up to you. How do you pronounce it? It is Kubernetes or Kubernetes. So in the shortest form is K8. So it is better to say it as K8. So today, this chapter is one of the most important chapters for DevOps engineers. As a DevOps engineer who are working on Kubernetes, we must know how the architecture of Kubernetes looks like. We have to see the deep inside of Kubernetes and we have to explore all the components that Kubernetes has. So make sure that you subscribe DevOps Molvi. We are going to learn tons of Kubernetes concepts. As I told you, let's get started. Alright guys, so in the beginning, we must know a general or a very basic overview of Kubernetes architecture. And that's what we are going to do in today's lecture. We are going to have a quick look on how the general overview or how generally the Kubernetes architecture looks like. So there are, by the way, a lot of Kubernetes components and we have to discuss them each one by one, and I don't want to overwhelm you. That's why I have a plan to take you gradually, and from the very beginning we are going to learn how generally the Kubernetes architecture looks like. So guys, in general, there is a master node in Kubernetes. So that would be our master node. In Kubernetes, there can be one or more than one master nodes. But for the sake of today's lecture, I'm assuming that we have only one master node. Okay, this is my master node, and it is running Linux. So you can say that it is a Linux box and we are going to treat it as our master node. Now in Kubernetes architecture, we can have one or more worker nodes. So this would be my first worker node. Okay, worker node 1, and that would be my worker node 2, worker node 2, and this would be my worker node 3. Okay, worker node 3. So in this simple, and that is actually my cluster. Okay, now that whole thing is known as a Kubernetes cluster. So this cluster contains one master node and 3 worker nodes. So this is my K8 cluster, and this cluster contains one master node and 3 worker nodes. You don't have to worry about node. Node means a Linux machine, a Linux server. So this is also a Linux server, and these are also my Linux boxes, Linux machines. Every node or every VM should have Linux installed, and worker nodes communicate with the master node. Now there must be a question in your mind. So you understand the Kubernetes cluster. This is the very beginning, or you can say the very general overview of how a Kubernetes cluster look like. This would be the Kubernetes cluster architecture, where we have one master node and we have 3 worker nodes. All these nodes are Linux boxes, Linux virtual machines, and they are running on the cloud or on your on-prem data center. So now we know that we have three worker nodes and one master node, but the question must come up in our minds that how these nodes communicate with the master node and how the actions that are triggered from this master node are executed on these worker nodes. How the commands, okay, Kubernetes master node is the bigger guy. It should send commands to these small guys, okay? And how these commands are executed on these worker nodes, there is something behind the scene, and we have to understand it. But first, we must know that master node, there are, by the way, more components. We are going to gradually discuss each component. We have components on master node, we have different components are on worker nodes. But to make it more simple so that you can quickly get the general concept of how K8s work, we have this API server. This is one of the core components of master node. Which one? API server. Every action that is triggered, every command you can say that is triggered, that is executed on these worker nodes, it is sent and by using this API. So we have this API that is used to trigger actions, to trigger commands, and those commands should run on these worker nodes. And those commands are used to manage pods or containers inside those pods, okay? And that would be actually our next step to understand about pods and containers running inside those pods. But for now, we must know that we have this API server, and this API server on the master nodes triggers actions, triggers commands. So how worker nodes know which command do we have to run or what do we have to do? So we have a Kubelet service, okay? So Kubelet service comes with a Kubelet agent. So I have to install this Kubelet agent on each worker node, okay? Because API server on master node communicates with these worker nodes using Kubelet service, and we have Kubelet agent should be installed on each worker node. So I will use Kubelet. Okay, this is an agent, okay? Kubelet agent, and this is also Kubelet agent. So we have, if we are going to expand our cluster, for instance, if I am going to add 5 more worker nodes, then I have to install the Kubelet agent on all these worker nodes so that they should communicate with the master node. Otherwise, master node should not know how many worker nodes should I have to manage. And using this Kubelet agent, those worker nodes talk with the Kubelet, the master node's API using the Kubelet service. We have this Kubelet service. I hope that now you are getting my point. And this Kubelet service using the Kubelet agent, we have to install Kubelet agent. Once Kubelet agent is installed on all these worker nodes, it uses the Kubelet service. And that Kubelet service from each worker node talks or communicates with the API on the master node, and that's how the actions are triggered between master and worker nodes, and that's how master node watches and runs commands, actions on all these worker nodes. So let me repeat it again. We have this API server on the master node. Okay, the master node is the cockpit, just like we have in any aeroplane. So we are going to discuss control plane as well, and what are the components of a control plane. But for now, we have this API service, and this API service using the API server triggers actions or commands and those commands are executed on these worker nodes using the Kubelet service. And Kubelet agent uses this Kubelet service to communicate with the API. That's how worker nodes communicate with the master node, and that's how master nodes communicates with these worker nodes. I hope that now you understand the concept. So in short, I would say that without this API server on the master node, there would be no communication between the master and the worker nodes. Alright guys, now let's explore worker nodes and master nodes more. We need to understand that these worker nodes are responsible for running the containers. Okay, your containers are running inside the pods, and your pods reside on these worker nodes. Okay, so worker nodes are responsible to run all these containers inside those pods, and also additionally they are also responsible to run every command or every action that is executed from the master node. So in simple words, the master node is the big guy. It is your proctor, it is your monitor. It is used to manage these worker nodes. And worker nodes are the small guys, the responsible guys that have to execute, have to run the commands that are actually triggered from this master node. And also the master node, being the big guy, it is responsible for maintaining the cluster's state. So it has more responsibilities as compared to these worker nodes. Not only that guys, master node is used to deploy the applications, scale the applications, and manage all these containerized applications that are running on these worker nodes. Now you understand the responsibilities of the worker nodes and the master nodes, because being the big guy, master node has higher responsibilities. It has to maintain the cluster's state, it has to schedule, scale, and manage the applications, and worker nodes run all those commands and actions that are triggered from this master node. So guys, this was the simplest possible Kubernetes architecture, but now we have to expand it. We have to know more what's happening inside this master node and what's going on with these worker nodes. So let's have a deep dive again. Alright guys, now let's draw a cluster with one master node and two worker nodes. I'm going to draw a Kubernetes cluster. That would be our cluster with one master node. Okay, this is my master node, and I have these two worker nodes. Okay, now I have two worker nodes. This is worker node 1 and this would be my worker node 2. So master node is also known as control plane in Kubernetes. Okay, this is my K8 cluster, K8 cluster, and this cluster has one master node. And I told you that there can be one or more master nodes, but for today's lecture, I am assuming only one master node. So we can say master node as control plane. And I have shared the example of the cockpit of any aeroplane. From cockpit, the whole plane is managed and run, okay? And in Kubernetes cluster, this is actually the control plane which manages the whole cluster's state. It watches out for any issues, and we have this master node also known as control plane, okay? Master node. So you don't have to confuse between master node and control plane. This is the Linux server, the big guy, okay? And it manages the whole cluster's state. Now there are a number of components inside this master node, or we can say control plane. We have discussed only one, which is the API server, okay? But we have other components as well. And also API is actually the central point, and using this API server, the whole communication is carried out using the APIs, and that's what API server handles. So I have this API server, and I have other components of the control plane like Kube scheduler. Okay, Kube scheduler. And don't worry guys, we are going to discuss each term in our upcoming lecture one by one. Every terminology of Kubernetes would be explained in detail, but for today's lecture you must know what are the core components of a Kubernetes cluster. And in master node we have control plane, and in control plane this would be our main component API server. We have Kube scheduler, we have controller manager. This is my controller manager, and I have a database which is etcd. Okay, now these are actually the four major components of a control plane, or I can say the master node. The first is API, Kube-API server. Okay, this would be, so the first one is Kube-API server. Now I would control plane components. Okay, number one, Kube-API server. The Kube-API server plays the most critical role of listening to every request, whether it is coming from the worker nodes or from the components inside the master node. Alright, so Kube-API server not only communicates with these worker nodes, but it also controls the other components like Kube scheduler, controller manager, and etcd. So we can say that it is an initial gateway to the cluster. Every request that is coming from the worker nodes should come to first the API server. So API server is the core component that listens to each request coming from the worker nodes. And if we are going to create more new pods or delete the existing pods, Kube-API server is responsible to do that. So the first important component of control plane or the master node is API server, Kube-API server. Now the second is Kube scheduler. Kube scheduler is used to schedule the pods on these worker nodes. As the name says, it is used to schedule pods on these worker nodes. But if we are getting any request of scheduling pods, it should go through this API server. So I would say that this Kube scheduler will talk or will communicate with the API server, and then API server will allow this Kube scheduler component to schedule pods on each worker node. So after the Kube scheduler gets a go ahead from this Kube-API server, the Kube scheduler decides on which node should I schedule the pods. Alright guys, the third component is controller manager. This is our Kube controller manager. Kube controller manager. Guys, since we know that this master node or the control plane is responsible for the whole cluster, it has to maintain the cluster stable. So it is responsible for cluster's health and stability. And that's what Kube controller manager does. With the help of this API server, Kube controller manager or Kubernetes controller manager actually maintains the cluster's health, maintains the current state of the cluster with the help of API server. So there are multiple controllers inside this Kube controller manager, and with the help of those controllers, the current state of the Kubernetes cluster is maintained. But since I told you that this Kube controller manager also communicates with the API server to maintain the cluster's current state. And the fourth component is etcd. Fourth is etcd. And guys, it is actually a database which stores all of the cluster's data. So guys, I have tried to explain all these master node or control plane components in simple words in order to simply understand what is a Kube-API server. Kube-API server is the gateway. Every request from these worker nodes comes towards this API server, and API server is responsible to create and manage or delete pods on these worker nodes. Okay. The second is Kube scheduler, which communicates with API server to schedule the pods on these worker nodes. Then Kube scheduler finds a good or healthy worker nodes to schedule new pods. So it is known as Kube scheduler. The third is Kube Controller Manager, and this Kubernetes Controller Manager actually monitors the current state of the cluster with the help of API server, and we have every data, important data of the whole cluster stored, and this component is known as etcd. This is actually the storage of the whole data of the Kubernetes cluster. So these are actually the four major and important components of any control plane or master node: API server, Kube scheduler, Kube controller manager, and etcd. API server is the gateway. It is responsible for the whole cluster, to create new pods, to delete the existing pods, and with the help of Kube scheduler, which is used to schedule the pods on the worker nodes, and Kube Controller Manager maintains and monitors the cluster's current state, and etcd contains the whole data of the cluster. So I hope that now you have a better and clear understanding of these four components of the control plane or the master node inside a Kubernetes cluster. Now let's quickly talk about the components of a worker node. What are the components that our worker nodes have? So this is actually more simple as compared to the master node. So in a worker node, we have the three major components. The first one is Kubelet. Okay, this is Kubelet, and this is actually Kube-proxy. And similarly in worker node 2, we will have a Kubelet, which is an agent Kubelet, and we have Kube-proxy. So we have Kubelet and we have Kube-proxy, and along with that, our third component is Docker, okay, or container runtime. But for this lecture, I am going to use Docker as our container runtime. This is my Docker, and we have this Docker runtime here as well, Docker. Okay, and now I have this pod 1, and I have these two pods in our worker node 2. 1, 2 pods. Okay, these are pods, and this is one pod. So what is a kubelet? A kubelet is the worker node's component that is used to manage the pods and the containers running inside that pod. And as I told you that Kubelet is also responsible to communicate with the API server on the master node. So we have to install Kubelet agent on these worker nodes, and this Kubelet agent uses the Kubelet service, communicates with the master node's API server, and API server which actually creates and deletes the pods using Kubelet service on these worker nodes. And at the same time, this Kubelet agent also communicates with the container runtime. It also communicates with Docker. Okay, so I would say that in worker nodes, Kubelet has more responsibilities. At the same time, it communicates with the API server on the master node, and it also communicates with the container runtime like Docker to create the containers inside the pod. In order to communicate with the master node, it uses the Kubelet service. So we have to install the Kubelet agent on these worker nodes. Now the last component is Kube-proxy. Now the Kube-proxy is a Kubernetes network proxy that runs on each worker node to route the traffic. So guys, I hope that now you know the core components of worker nodes. We have Kubelet, we have Kube-proxy, and we have a container runtime like Docker or Podman or Container. And in these components, Kubelet is the most responsible component of worker nodes, because at the same time Kubelet communicates with Docker, which is our container runtime. It also communicates with the master node's API server with Kubelet service, and it is also responsible for creating containers inside the pods. So it is not necessary that we must use Docker as the container runtime. As I told you that we can use Podman, we can use Containered, or we can use the Kubernetes CRI, container runtime interface. And Kube-proxy is the network proxy which is used to route the traffic, and it also forwards requests coming from different services like the API service or Kubelet service to the respective pods. So these are actually the three core components of the worker nodes, and we have these four core components of the master node or the control plane. So finally, what are the four core components of the master node or control plane? We have the Kube-API server. It is the most responsible components in any Kubernetes cluster. So the first component of control plane is Kube-API server, and it works as the gatekeeper. Every request has to pass through the API server, and it is responsible to create and manage and delete the pods on these worker nodes. The second component is Kube scheduler. It is used to schedule the pods on the worker nodes with the help of API server. The third component is Kube controller manager, which controls the state of the cluster. It monitors the state of the cluster with the help of API server and the controllers that are built in this Kube controller manager. And the fourth component of Kubernetes control plane is etcd, which is the database of our cluster, and it contains every information, every data of our Kubernetes cluster. And now, as far as the components of worker nodes are concerned, we have three major components of worker nodes. Kubelet. Kubelet agent is installed on all these worker nodes, and it uses the Kubelet service to communicate with the API server, and it is also at the same time communicating with the container runtime like Docker to create the containers inside the pod. And finally, we have this Kube-proxy, which is used as network proxy to route the traffic among different nodes in a cluster. So my apologies guys, I hope that every concept is clear, and it looks like overwhelming, and it looks like that there is a lot of stuff that is going on within a Kubernetes cluster. But to be honest, if we focus on each component for a couple of moments, we can get our concepts cleared. But don't worry, because these components, these terminologies are being used extensively in our upcoming lectures. So for now, that's it for today's lecture, and we have discussed this simple Kubernetes cluster with one master node and two worker nodes. So this is actually a simple Kubernetes architecture, and it is a simple Kubernetes cluster. And in the next lecture, we are going to have some more details about these components. And after that, we are going to install Kubernetes, and we are going to create a minimal Kubernetes cluster of our own. So stay tuned. Make sure to subscribe DevOps Molvi. I will watch you in the next lecture. Have a good one. Bye.